Good evening, everyone. In the last sessions, I think we discussed very clearly. So, various programs related to list data structure and even the programs related to string data structure and even combination of those also we covered very clearly in the last sessions. Now, in today's session, we are going to talk about one beautiful topic, which is nothing but recursion. Very, very important topic, recursion. So, what is mean by recursion? What is mean by recursion? Generally, it is related to the functional programming concept. Okay. So, what is mean by function? In general, sir, when we are writing a set of instructions and if some kind of coding is repeatedly required in our application or in our project, for example sake, I am telling I want to insert some data into database, suppose maybe student records. So I'm reading some data from the user and I'm collecting all the required information, and I need some extra special attributes also. I calculated all the attributes, whatever required. Then I want to write that data into the database. That is my requirement. So now I'm reading the details of a first student. Then I'm reading the details of the second student, then third student, like that. See, when you want to write the information, is it a common requirement or not? Yes. Repeatedly required task is there. One is we have to establish the connection with the database. Second, we need to identify all the parameters. We need to prepare one SQL query, and then you have to insert. Okay. So since every time these things are required, that's why if anywhere repetition tasks are required, highly recommended to go for this functional programming. Okay. So let me give some introduction related to this. So first we are going to talk about a function. A function, or in other words, we can call it as a method. A function or a method which is called by, okay, which is called by itself is called as recursive. Okay, recursion is called as recursion. A function which is called by itself. Okay, and in this the method or the function which is invoked is called as recursive function. Okay, so in that recursion, whenever we are calling a method by itself, okay, the method which is invoked in that, or the function which is invoked in that process, is called as recursive function. In short form, a function which is called by itself. Really, there are n number of requirements are there for this purpose. Okay, n number of requirements are there for this. And once if you know the pattern of the program, by using this recursion, we can able to solve any kind of big programs also. So that kind of facility we can able to get with the help of recursion. Anyway, we are going to see all those problems, but for your understanding purpose, I am taking one small example program. Okay, let us take I have test.py is there. Now listen carefully. I'm defining a function. Within this, I'm printing some message called good evening, something like that. So what will happen? Is this good evening message is going to execute or not? As of now, it won't execute. The problem with this is, sir, we didn't create it. I mean, we didn't make a call to that. If you are trying to run the program, see what will happen. Nothing is printed on the screen. The reason for that is we created a function, but someone has to call that function, right? Yes. Now I am calling fun. What will happen? So the control will from fourth line to first line it will go, and it will execute all the instructions present in this function, and it will terminate. So now what is the output that we are getting? Good evening like this. Okay. Sir, can I call this function multiple times? Can I call this function multiple times? Yes. Based on your requirement, you can call any number of times. Here I called 2 times. So we are getting the message 2 times. Good evening, like that. So function means what? A reusability component. Recursion means what? Inside the function, if you are trying to call the same function again and again, then this process is called as what? Recursion. As of now, programmatic example for the recursion I didn't covered. Simply I have taken one function and I called that function 2 times, so that that reusability concept is applied every time we are not doing our own implementation for the function. It is a only one time declaration, and we are calling that by any number of times. Okay, this is nothing but what? General functions, sir. Now slowly I am trying to implement recursion for this, and see what will happen. Here already one function is there. Inside this function, after printing good evening, I am going to call this function. Okay, if you want, I will show you diagrammatically, see what will happen. First we are calling some function called f. So it is printing a message called good evening. This is the first job. And in the second place, again it is calling the function. So what will happen? Again it is doing 2 tasks. Sir, first task is it will print good evening and it is calling a function. Sir, again it is going to print good evening. Again it is going to call function. Sir, do you know this process is a never ending process? Can I say, is it recursion or not? Yes. Of course, if we want, we can provide some conditions and we can make that function call to terminate at finite steps. But as of now, we didn't provided any condition, right? So what will happen? These functions are going to execute continuously. Okay. But sir, how many times? Is it going to lead infinite execution? Yes. But unfortunately, sir, do you know this Python, Java, these programming languages are maintaining some data structures to hold this method calls control. Okay. So what they are going to do is, depending on your memory capacity, they will create one data structure called stack. This is the first call. Corresponding entries will be there. Second function, corresponding entries will be there. Third function, corresponding entries will be there. Fourth function, corresponding entries. Up to certain level, it will store. Once if it is completed, then you are going to get an error saying stack overflow. Stack overflow. This is one kind of error. But luckily in our Python, direct statement they have given like recursion error. Okay, because too many method calls, it is unable to respond. Okay, let me execute this code and cross check whether it is working properly or not. Now I am running this code. You can see, sir, py space tester.py, it is keep on executing, but at last you can see recursion error. Maximum recursion depth exceeded while calling a Python object. While calling the Python object, maximum recursion depth got exceeded. Like that, we are getting one error. Okay, this is nothing but internally how we are using this recursion. But strictly speaking, this is never recommended. Why? Because if there is no termination, definitely issue will be there with the help of method calls. That's why, I mean, even with respect to memory also, you are going to get the biggest problems. That's why how we are going to resolve this, that we will see later. But as of now, recursion means what? How we are going to run these recursion programs with the help of a small example I covered for you people. Please confirm everyone, is the concept of this recursion, is it clear for you people, guys? Please respond.
Sir, in
Yes.
Python, what is the maximum limit for Stack Overflow error?
So actually stack overflow error we need to get. Even in Java, in other languages also, we will get a stack overflow, but they have renamed this error as recursion error. When we are making maximum number of calls, we are getting this. How to reduce, I mean, how to remove this kind of error message means we have to make this particular function to execute only n number of times. That n you have to provide. How to implement that I will show you. So we can control the loop to execute only fixed number of times. Okay, got it?
Sir, what is the fixed number in Python?
What is a?
What is the fixed number of function for in Python?
I'm not getting your question, sir. What is a?
Wait a while, sir. I will ask the same question again after some time.
Okay, okay. Can you put into a chart window? So,
Definitely, sir.
right. Everyone feeling comfortable up to this, whatever I covered?
Yes, sir.
Right. Sir, next there are two types of recursions are there, sir. Okay. There are two types of recursions are there in every programming language, not only in Python. Even if you take any programming language, there are two types of recursions are there. Okay. What is the first one is finite recursion, and the second one is infinite recursion. Okay. In general, so there are two types of there are two types of recursions are there. One is nothing but what? Finite finite recursion, and the second one is what? Infinite recursion. Like that we have two types of recursions are there. And let us talk about in detail. Sir, infinite recursion means we covered already. What is mean by infinite recursion? So there won't be a proper end. Okay. So the recursive method is going to execute. Okay. So infinite times. So I can say it is never ending process. But so Python terminates. So this kind of recursion automatically, sir, when, sir? If automatically, so if stack got overflow. Anyway, we can't give guarantee for that. Automatically it will overflow. How many number of stack frames will be there? All these things we can't able to measure as of now, theoretical part. So this is nothing but example program for this, and I can say this is nothing but output what we are going to get for that. I'm removing all these unnecessary things like this. So what is the opposite for this? Finite recursion. Finite recursion means what? So finite recursion means which is going to stop. It is a recursive method is going to execute finite times. Okay. So when it is going to stop, sir, it stops automatically. It stops automatically. Okay. Automatically. Once if a condition is satisfied. Once if a condition is satisfied. Okay. Then such a type of recursion is called as finite recursion. Okay, which is going to stop automatically. Sir, can I make this program as a finite recursion? Yes, you can put a proper condition and it will be executed only those many times. Best example here, sir, do you know I'm going to pass some value, sir? How many times I need to wish that a message called good evening? I need to wish 7 times. Okay. So I'm receiving some number n. So what we are going to do, I will print good evening. The output of this program will become, sir, it will print good evening. Then what will happen immediately? So we are calling the function by taking n minus 1. So what is the value of n as of now? Sir, n value in this example, the value of n is 7. Now it will be called for n minus 1. That means your n value will become 6. Since it is a recursion, again it will come here and n value is 6. It will print the message called good evening. So and again n value is 5. Again it will print good evening. Again your n value will become 4. Again it will print good evening. Next your n value will become 3. Again it is going to print good evening. N is equal to 2. Good evening. So n is equal to 1. Good evening. How many times we need to print? 7. 1, 2, 3, 4, 5, 6, 7. Completed, right? So means what? Whenever n value will become 0, can I stop the process? Yes. That a condition we have to provide. If the value of n is equal to 0, then simply I am going to return. Return means what? I will stop executing this. The beautiful keyword what we have in Python is nothing but return. The main purpose of return is, once if you are using return, directly the control is going to come to the caller. So who is calling this function? For them it is going to return. Okay, without returning any value, no problem, you can. Otherwise what will happen? Good evening message and it will call for n minus 1. So this is nothing but the never ending process. When it is going to stop? Whenever the argument will become 0, then it is not printing anything and it will stop. Now let us run this program and see what is the output we are getting. Sir, count how many times we got this. 3 plus 3, 6 plus 1, 7 times we got this message. Sir, I can say this is nothing but what? Finite recursion. Okay, so infinite recursion means what? There won't be any ending process. Finite recursion means it will be terminated at a finite number of steps. Okay, sir, everyone got a clarity about this finite recursion and infinite recursion? Please confirm.
Yes, sir.
Sir, can we have exit keyword in a Python? Like we are having a exit keyword in a C?
Huh?
Can we have a exit keyword in a Python? Like we are having a exit keyword in a exit, exit.
Yes, we can exit from the control.
Can
We
we
can.
have the means I'm asking that can we in Python the exit keyword is there or not?
Yes, exit. You are talking about exit, right?
Yes.
Exit is a function, not keyword.
But sir, in
Exit
C,
in C also exit is a function, right? It is not a keyword. Okay.
it is just saying that coming out from the function.
Not only coming
Um,
out from the function, exit is used to terminate the total program execution. It is not related to the function. It is related to the program. If you want to stop the total program, if you want to terminate the total program, then you have to use exit of 0 or 1, something like that.
Got
It
it,
will
sir.
time, it will give some time, 1 or 2 minutes, and then it will terminate. Got it?
Like sir, exit one will be means successful termination and exit zero means unsuccessful termination.
Not like that. So exit function is going to take, maybe it will be internally there, but we are not required to see about this. As of now, it is not required, right? What is the need to bring this exit concept here?
No, I was asking because the return keyword is there. That is why contrasting the same with exit keyword.
You are telling you can stop this infinite recursion by using exit keyword.
Yes, I'm asking that. Can we do?
You can, but the total program itself is going to stop, right? See, whenever you are calling here, if you are using exit means what? At the first time itself, it will stop.
Okay, got it.
Okay. Exit means at any point of time, directly without seeing front and back, just come out from the function.
Got it. Thank you.
I think there is no use case for the exit. So then what is the need to write the program itself is useless. Got it?
Yes, sir.
Sometimes if frames, these things are not closing, then we can, but here not required. Any queries?
Yes, sir. I was asking the question that in just see the last line. Maximum recursion depth exceeded. I was asking the maximum recursion depth.
That's what I told, right? Internally, it is going to maintain one stack actually.
Stack data structure. Got it.
So
Activation
one
record kind of
stack
thing.
is completed. So it is maintaining some stack frames. Once if it is completed, if it is full, then automatically it is going to terminate by giving the message called recursion error, and the description about that message is what? Maximum recursion depth got exceeded, like that. Okay.
Got it.
Right. Next one, sir. So there is one terminology is there with name base condition. Okay. There is one more terminology is there with name base condition. Sir, what is mean by base condition? Base condition. Sir, what is mean by base condition? Very simple. Inside, okay, inside recursion to stop, okay, to stop recursion, inside recursion, to stop recursion process, okay, at a finite number of steps, at a finite number of steps. So we can use this base condition. We can use this base condition. Okay. So we have to take, okay, we have to take this base condition. We have to take this base condition as a first statement inside a recursion call, inside recursion call. So if the condition is satisfied, so it terminates, it terminates. So else it continues the execution flow, it continues the execution flow. That's all. So such type of condition are called as what? Base condition. Sir, I request everyone to please be on mute. So if you want, you can see here, sir, in this example, can I say this n is equal to 0? This one is a base condition or not? Yes, automatically it is a stop executing the process. Sir, I want to execute only 5 times. First time, is your n is equal to 0? No. It will print good evening and it will call for n value is equal to 4. So is it equal to 0? No. It will print and it will call for n is equal to 3. Again, is it n is equal to 0? No. It will print and it will call for n is equal to 2. Like that, it is keep on calling, sir. It is keep on calling. So at a finite number of steps, what will happen? This condition is going to be evaluated. So what is the n value? Initially 5. After executing 5 times, since every time we are trying to reduce a unit value, once if it is got reached to n is equal to 0, since the condition is going to satisfied, it will return. Return means the control will come out from this. I can say such a type of condition is called as what? Base condition. Now let us execute this. Is it going to print 5 times or not? You can cross check. So good evening, good evening, good evening, good evening, good evening. Total how many times we got? 5 times. This is nothing but base condition. So what is mean by base condition? Inside the recursion, to terminate our recursive process at a finite number of steps, we are going to write some condition. Such type of conditions are called as what? Base conditions. Okay. Feeling comfortable up to this?
Yes, sir.
Yes, sir.
Right. So the next one, what we have, even sir, we can divide this into two types. So based on the function or method calls, function or method calls. So we have two types of recursions are there. Sir, what is the first one here is we have direct recursion. We have direct recursion is there. Second one, we have indirect recursion is there. What is the first one? Direct recursion. Second one is indirect recursion. See, direct recursion means, directly I will take example. Direct recursion means, suppose if you have a function called fun, inside these, we are having some group of lines like this, I mean group of statements. It is going to execute all the statements. After that, we are calling the function. This one is called as what? Direct recursion. Sir, indirect recursion means what? Indirect recursion means we have two functions are there, like def fun1. It is having some group of instructions. In the middle, I'm going to call second function. And inside the second function, what will happen? Sir, it is having some sequence of instructions. After that, we are calling function. So what is the meaning of indirect recursion? One function is going to call another function. One function is going to call another function. That function again internally calls the first function. And this process is a never ending process. It is keep on repeating. So such a type of recursion is called as what? Indirect recursion. Got it? Sir, is the function types based on this? Is it clear for you people?
Yes.
Yes, sir.
Yes.
Right. Next one, when we have to go for recursion. Okay, so when we have to, when we can, or when we can go for recursion. Sir, when we can go for recursion? For small kind of programs, we should not go. Okay, so if the problem size is very big and we are unable to solve, okay, we are unable to solve the problem, so then we should go for recursion. This is nothing but what we have. And what are the various applications of recursion? Means where we are applying this recursion concept in the programming. We have so many techniques are there. So maybe in the coming classes we are going to discuss. One is nothing but binary search algorithms are there. Okay. Second one, so we have quicksort algorithms are there. In this also we are using, and we have merge sort algorithms are there. In this also we are using. Next, we have divide and conquer. Divide and conquer algorithms are there. In this also we are using recursion. Okay, like n number of applications are there. In everywhere we are using this recursion. In this chapter itself, we are planning to cover around 20 programs on purely on recursion. You people are going to get the complete idea how we are going to use this recursion in the programming. Okay, don't worry at all. Sir, this is nothing but what we have. So what is a recursion? What is mean by that recursion error? So internally, which data structure is used inside the recursion? Next, and after that, we have seen what are the two types of recursions, like finite and infinite. Next, direct and indirect recursion. What is mean by base condition? For what kind of algorithms we can take this recursion? Okay, and what are the various application areas are there for this recursion? I explained. Up to these theoretical parts, whatever we covered. Do you have any doubts?
No, sir.
No, sir.
Clear, right?
Yes, sir.
Right. Sir, with one small concept, I will wind up today. Okay. Now listen carefully. See, based on position, of recursive statement, again it is divided. Again, it is divided into two types. Again, it is divided into two types. Means what? Based on the position of recursive statement. On which position you are using. Based on that, again it is divided into how many types, sir? Two types. The first one is called as tail recursion. So it is called as perfect recursion. Tail recursion, which is called as perfect recursion. And the second one, non-tail recursion is there. Non-tail recursion. So what is mean by non-tail recursion? It is called as backtracking. I think after recursion, our immediate topic is somewhere backtracking is there. Okay, I will cover this after recursion. You can see how it is going to work. So based on the statement, based on where you are writing a recursive statement, that based on that position, it is divided into two types. So now what is mean by this tail recursion? What is mean by this tail recursion? Very simple, sir. A recursive function is called as tail recursion if the function, okay, if the function does not contain, if the function does not contain, okay, any statement, a function does not contain any statements after recursion method or function call, recursive function calls. You can see in this previous program, sir, can I say this fifth line is the recursion call, right? Yes, a function of n minus 1. This is called as a recursion call. After this recursion call, do we have any statements? No. Then such a type of recursion is best example for tail recursion. Okay. Sir, I will take one meaningful example so that you will get clarity. See, I am taking a function which will take a number n. Okay. And if that number is equal to 0, I will stop the process. I don't want to do anything. Otherwise, I am printing the value of n and I am calling n minus 1. That's all, sir. Now listen carefully. I am calling the function by passing the input as a 4. Sir, I will draw the diagram. Then only you can able to understand this. Have a look once what will happen. Sir, what is the value of n that you have given 4? So function of first time n is equal to 4. Is that value is equal to 0? No, sir. Print the value of n so that in the output what will become 4 will be printed. Then again it is calling n minus 1. So function of 4 will become again function of 3. Sir, is that n value is equal to 0? No. Print the value of n. It will print 3. Then call for, so function by passing 3 minus 1, which is nothing but 2. Sir, print is n is equal to 0? No. Print the value and call for n minus 1. Sir, your n value will become 1. Okay. Sir, then what will happen? Is the value of n is equal to 0? No. Then print the value of n, which is nothing but 1, and call for 1 minus 1, which will become 0. Sir, is n value is equal to 0? Yes, then terminates. So what is the output of this program? 4321. This is called as what? Tail recursion. Sir, what is mean by tail recursion? After the method, I mean after the recursion call, we should not take any statement. If you want, you can see what output we got. 4 followed by 3 followed by 2 followed by 1, like that we are getting. So this is called as what? Tail recursion. The output of this program is nothing but 4 3 2 1, something like that. Sir, what is non-tail recursion? What is non-tail recursion? Opposite for this. So a recursive function is called non-tail recursion if the function contains, okay, if the function contains statements, if the function contains statements after recursion function call. Let me take one example. I think same program, if you demonstrate, you will get clarity. See what I am doing. I am removing this print statement and I am keeping after this line. Sir, now this is called as what? Non-tail recursion. For this, I am changing the color and observe what is happening here. What is the value of n, sir? 4. Please listen. Is n is equal to 0? No. call n minus 1. That means what? This n will be called for, so function of n minus 1, which will become 4 minus 1, 3. But one statement is pending. What is that statement? Print of n. When it is stopped, when n is equal to 4, it is stopped. Then n is equal to 3. Is it equal to 0? No. Then we are calling function of n minus 1. 3 minus 1 will become 2. But this statement is pending. These statements will be stored inside the stack. What is the second statement? That value of n is equal to 3. Now the value of n is equal to 2. Since it is not equal to 0, again it is going to call 2 minus 1 will become 1. Now what will happen? One print statement is printing, waiting. What is the value of n there? Then f of 1, n value is 1. Sir, is it n value is equal to 0? No. Then again we are calling 1 minus 1, which will become 0. And what about the entry, sir? Can I say n is equal to 1? Yes. Then whenever function value will become 0, it is going to stop, because we have given the base condition, right? So what is the output of this program? After this print statement will be executed. How many times? In the stack, all the details will be there, right? In this example, n is equal to 1 means what is the value that we got? Sir, 4. Okay, 4. I think these statements is going to be executed in the reverse direction. Is the correct program?
Yes.
Yes. So n minus 1. Then method calls are going to become. What is the value of n here? 1. It will print 1. Then this entry will be deleted. One more time it will come. I mean, while reversing that. N is equal to 2. It will print. And one more time it is going to come, because stack entries are there. N is equal to 3. It will print. And one more time it will come. N is equal to 4. It will print. Sir, this is the output what we are getting. Okay. Is there any difference? Yes. If you are taking any function, recursive function, before this recursive function, if you are taking any statement, then it is called as what? Tail recursion. After this, if you are taking any statement, then it is called as what? Non-tail recursion. There is a difference. I think this example is clearly explained. So how it is going to be happened internally. Now you can see. Sir, previously we have 4, 3, 2, 1. Now we have 1, 2, 3, 4 like this. This is the way, sir. What is mean by finite recursion, infinite recursion, direct recursion, indirect recursion. Next and after that what? Tail recursion and non-tail recursion. Sir, feeling comfortable up to this?
Yes, sir.
Any doubts, please confirm.
Sir, can we say non-tail recursion is nothing but backtracking?
Yes, non-tail recursion is called as backtracking. So because you can see we are going to find for the solution. If a solution is not coming, we will move one step backward. You will get this, sir. I will explain with the help of examples. There you will get in detail. Okay.
Got it. Thanks.
Sir, hello.
Yes.
Sir, can you explain once more this example?
Sir, here you understood the previous example, right?
Yes, sir.
So in the previous example, what we are doing, if you see the diagram here, one second. If you see this example, in this example, so the value of n is equal to 4 means first it is a calling the function. It is non-tail recursion. Let us go for tail recursion. So in the case of tail recursion, when n is equal to 4, what it is doing, it will print the value of n. That means 4 will be printed. After that it is calling. So 4 minus 1, 3. Then 3 minus 1, 2. 2 minus 1, 1. 1 minus 1, 0. Then it will stop. This is in the case of tail recursion. But if you take non-tail recursion, see what is happening. Assume the value of n is equal to 4. Is n is equal to 0? No. It is calling the function directly. Means what? Without printing this, again the control is coming. Sir, if the control is coming, next time it will execute all the things and it will come back, right? Because there is a statement. So how it is going to track that statements. For that, internally stack will be there. First time the value of n is equal to 4, some method call happened. Second time, so again for n is equal to 3, we are making a function call. For n is equal to 2, we are making a function call. For n is equal to 1, we are making a function call. Whenever n is equal to 0, it will stop. But this line is never executed, right? But we have a chance. Why? Because it is a recursion. After doing all your activities, it is your duty to execute the pending instructions. Now what will happen? That pending instructions, where it will get the value of n, because you are using only one variable. It is coming from the backtracking. What is the first value of n? 1. Then corresponding entries will be deleted. What is the next value? 2. Corresponding entries will be deleted. What is the next value? 3. Corresponding entries. Next value is 4. Corresponding entries. Like that, it is going to delete. Got it?
Okay, sir. Okay, sir.
Right, sir. So with this, I'm going to stop today's session, sir, because actually I'm not feeling well, but almost 2 to 3 days we kept leave. That's why I have taken today's session. Okay. So anyway, tomorrow and the day after tomorrow, we don't have any class. As a weekend, I have another class is there. And we are going to cover recursion based programs on Monday. Monday we are going to discuss. Sir, probably I will take Monday from 6:30 only, 6:30 p.m. to 8 p.m. Okay. So Monday we are going to finish these recursion related programs. Okay. Right, sir. Thank you. I will upload the running notes now itself. Download and practice the programs. Okay.
Sir, when we can expect the completion of the code?
Maybe, sir, maximum by this month end. Because once if the recursion, sorting and searching linked list got completed, means the rest of the things are very easy.
Got it.
Right. Thank you.
Thank you.